Hi everyone. In the previous lessons we've been looking at the compound angle formulae and the double angle formulae for sine, cos and tan. And now we're going to look at something slightly related that's called the half angle formulae. So let's have a look at the tan double angle formula. So tan 2 alpha equals 2 tan alpha over 1 minus tan squared alpha. Okay, so that's something we've seen in the previous lesson. Now, this is useful because it generates an expression that's completely in terms of just one trigonometric function, sine, cos, or tan. It's just completely in terms of tan. So let's do one this time, but for tan, let's just say tan theta. So that would become 2 tan theta on 2 because we need to halve the angle. Like this was twice as big as this, so my theta needs to be half the size, over 1 minus tan squared theta on 2. So that would be my expression there, and I haven't really done anything new. It's just instead of writing 2 times something, I've just put in theta, and it would have to be half as small. Like this is twice as big as that, and so is the case in my other second expression. Now, just for the sake of simplicity, let's call tan theta on 2, just call it the letter t, so we don't have to keep writing that out again. So tan theta equals 2t over 1 minus t squared. Okay, well, if that's what tan theta is, keep in mind tan theta is the opposite on the adjacent. So we can generate a right angled triangle from this. So let's generate a right angled triangle. So we would have something like this. We would have theta here, and we'd have 2t, we'd have 1 minus t squared. And if we find the third side using Pythagoras theorem, we will find that it is 1 plus t squared. That's what that third side's going to be. So now we have a way to express sine, cos, and tan, all of them in terms of t. We can express sine theta in terms of t and cos theta in terms of t. So this is useful because it gives us a way, if we have an expression with sines and cos and tans all floating around in there, we now have a way to convert all of those to t, to tan theta on 2, which is good. It's always nice if you can consolidate it into one function. For instance, if it's a trigonometric equation, it's a lot easier to solve if there's just one variable floating around. So from this triangle, we'll get sine theta is equivalent to opposite on hypotenuse, so 2t over 1 plus t squared, and cos theta will be equal to 1 minus t squared over 1 plus t squared. And as we saw before, tan theta is going to be equal to 2t over 1 minus t squared. So this is useful because we can, if we have coses and sines and tans all floating around, we can write their equivalent expression in terms of tan theta on 2. All of these can be related to an expression just involving tan theta on 2, which is very helpful for cleaning up, like I said, trigonometric equations or something like that. So let's have a look at a simple example. Let's say that let's write sine theta plus cos theta just in terms of t, just in terms of tan theta on 2. So what this would be is 2t over 1 plus t squared plus 1 minus t squared over 1 plus t squared. And since we have a common denominator, it would be 2t minus t squared plus 1 over 1 plus t squared. So that would be our expression for sine theta plus cos theta just in terms of t. So if we had to, for instance, solve an equation where sine theta plus cos theta equals some constant, then instead of dealing with these, we could convert it to this and just solve that equation equal to some constant and solve the trigonometry. And at the end, just remember that tan theta on 2 is actually what t is. So we'll leave that lesson there. The main thing to take away from this lesson is that all the functions, sine, cos, and tan, can be expressed in terms of tan theta on 2. And we can draw the triangle that's derived from the tan double angle formula to find out the expressions for sine theta and cos theta and tan theta, I guess, in terms of tan theta on 2. And once we know those, we can convert all the functions in terms of t if it's beneficial to do so.